Okay, threshold stimulus. Minimum strength of muscle stimulation to cause contraction. So what this means is, if not enough electrical signal came in, then if it's not strong enough, then there's no contraction in the muscle, is what this refers to. So the stimulus refers to the electrical signal. If the stimulus is strong enough, if it reaches threshold, and so threshold means, just think, is it strong enough? If it is strong enough, then an action potential electrical signal can be generated in the muscle. And then if the electrical signal was generated, we saw from those steps, calcium gets released from the sarcoplasmic reticulum and leads to contraction. Okay, so one action potential, if it came to the muscle, if it released enough acetylcholine, then it can cause a muscle contraction. Twitch. Twitch refers to a single contraction, single muscle fiber to a single impulse. So I'm going to write down here, single contraction, relaxation is called a muscle twitch. On this graph, the left side is showing the contraction, the strength of the contraction. The bottom part is showing time. Okay, so here it says the stimulation, meaning the electrical signal that came from the nerve cell, it was strong enough and it caused contraction in the muscle. It goes up, and then of course if it contracts, it needs to relax. Okay, so one contraction relaxation is called a twitch. But of course, there isn't just only one muscle fiber in the muscle. There are many, many muscle fibers. And there can be, depending on the muscle size, many motor neurons that go to the muscle. So here in this example, what they showed here, two neurons, here's a neuron, and these neurons may be activating the different muscle fibers. Yeah, so I guess this motor neuron of motor unit 2, this is going to the red fibers, and they showed this other one, motor unit 1, going to the purple ones. Okay, but so know the definition of motor unit. It's basically a motor neuron and the muscle fibers that it controls. And so a whole muscle consists of many motor units because there are many muscle fibers and most likely more than one motor neuron. This is kind of interesting. You don't need to memorize these, but it says here coarse movements, so basically like lifting something with your hand, are produced with large numbers of fibers. But precise movements, so basically writing, drawing, precise movements, are produced with fewer muscle fibers in a motor unit. So having fewer muscle fibers allows for more control, so you can control them much more easily. Okay, so recruitments. Well, if you activate more muscle fibers, then the muscle is going to contract much more strongly. So increase in the number of those motor units, more force will be produced. It's kind of interesting too. Certain motor units are activated first in a muscle, then others are activated if you need more strength for the muscle contraction. Yeah, so then again, it's just going to continue until more units are activated and the contraction. Okay. Summation just refers to how you are activating more muscle fibers and the contraction is increasing. Okay, so what this shows here is partial or complete tetanus. So in this one, this top graph is showing contractions, relaxations, but it's not showing how the muscle contraction strength is increasing. It's not really increasing, right? It's not really increasing. But in this next one, here we're slowly increasing the contraction because of more fibers getting activated. And these arrows at the bottom of these graphs, these are referring to the electrical signals that are coming into the muscle and activating the muscle. So if the contraction increases slowly like this, and we're also seeing it on the bottom graph, the third graph. So slowly the muscle contraction increases. Yes, some muscle fibers might be relaxing a little bit. This is called a partial contraction. Okay, so I'll just do it here. Partial tetanic contraction or tetanus, but don't think of this as the bacterial tetanus. So this is just referring to the contraction as it slowly increases. Versus here, muscle contraction increases, but if the muscle stays contracted, so think of it like if you're holding something, if you're holding up a book, your muscle needs to stay contracted in order for you to hold a book. But then of course you're going to end up letting go. Okay, if it stays contracted, this is called complete tetanus. Oops, sorry, it's just supposed to say tetanus. Okay, so when you see these two graphs, partial tetanus versus complete tetanus, oh, and also if you remember the twitch, can you correctly label these? Alright, so that video showed the different types of contractions. So the isotonic contraction, there are the two types of this. Now with the isotonic, the muscle is contracting and muscle changes in length. Okay, so the muscle is doing work and it's changing length. The one type of isotonic contraction, the concentric, here know this as the muscle is shortening and you are doing something against gravity. And so here in the bottom picture, lifting up something against gravity is concentric. Okay, so here the muscle shortens. Now letting it down, going with the gravity, here the muscle is instead lengthening, stretching, but it still has some force to it. It is still contracting. So then the eccentric, know this as the lengthening contraction. And so this one goes with the gravity. Okay, versus isometric. Here the muscle stays contracted. So this is when you're holding something. Okay, so it says here no movement, but your muscle is still producing a force in order to hold this object. Now, here the muscle contracts, does not change length, but it stays contracted. So we call that an isometric contraction.